Right, welcome back, everyone. This is Michael Trippy, your host here. Johnny Rush, of course, is my online handle. Um, got some things to go over. On the last stream, we were modifying or creating actually, it was the second modification to the waypoint system and some AI. And we talked about some changes that we were going to make. And one of those changes was to allow the waypoint system to be passed in a starting waypoint entry point and a final destination instead of having hard-coded values. So that was something I went ahead and worked on. We have that implemented, and we'll go over that in a minute. Um, the other thing I wanted to show, what I have up here on the screen, is a modified animator for our sample enemy tiger. And in the previous one, we actually had the going from the idle state. We had the tiger go to a roar, I believe, and then to a strike, and then back down to a roar, and back to the idle. So, and that wasn't quite set up well. And what I decided to do was make a slight change. It seemed to work better with the limited animations we had with the tiger, which again was a free asset from the Unity store. And I also changed up some of the parameters we had set up here. We originally had speed, is attacking, and is roaring. I got rid of is roaring and changed this to is hit. And essentially what we're going to be doing is when our tiger is actually attacking our player, it'll strike the player, and so the tiger strike animation will be triggered in that case when he's attacking, when his attacking is set to true. I decided to reserve the roar for that animation for when we get to the point where our player is actually shooting at the tiger, which is the enemy, and then when the enemy is hit, he'll do a roar before he comes charging at us to attack. So that's been separated, and a couple of the changes, if we just go ahead and click on the tiger roar here, I did want to show, first of all, I was a little bit unclear on how that has exit time worked, and the way it works is when that's checked, then the transition for that exit will complete to its entirety, as well as the clip itself. So when that's checked, it'll play the entire clip. Now that seemed to cause issues with what I was trying to do in code to have it update, more frequently. And so I decided to remove that as exit time and only use conditions, which I found out it's one or the other. I mean, if you don't have conditions, then you have to have an exit time, but if you don't have an exit time, you have to set up a condition. So once I went ahead and straightened all that out, everything seemed to work much better. So going from the tiger idle state, he can go up to a walk and then to a run, and back down from a run to a walk and to the idle state. Now from the idle, he can do a roar or a tiger strike, and I've clicked on the tiger roar so you can see the condition that was set up. Basically, it's if this is hit Boolean parameter is true, then while that's true, then it'll go into a roar. Now I don't have any conditions set up for the return. What I did was leave for the transition back from roar to idle, I left it at the default of using the has exit time. This way the entire animation can complete, and then it'll transition back to the idle state automatically. And then of course the idle state is checking, and if is hit is true again, it'll continue and do all that back to roar, go through a loop, more or less. Not more or less, but it actually does. As long as those states are true, that is hit is still enabled, by the time it goes through that animation, it'll do the animation a second time. But usually by that time you've updated your code in the next frame or so to switch that off. So it's just a way to trigger the transition from idle to roar. And the way it's set up right now with a has exit time on the return, it'll make sure that that animation completes successfully or all the way through before it moves on. I did the same for the Tiger Strike. You'll see we have a is attacking condition. So while the tiger's attacking, or while we turn that parameter to true from code to say that the tiger is attacking, it will trigger this animation for the tiger strike. And then again on the return, same thing, no condition, just left the default of has exit time checked so that it finishes out the strike animation and then comes back to the idle state. Now for the walk, the transition from idle to walk and walk to run, you see the has exit time is not checked on either of those. The same with going back, because I want it to go ahead and just transition automatically based on the speed variables, which could change. And so we've got a few over here, and I don't know if I need to still play around. I may could remove this is attacking completely, because we do although he does actually move while he's attacking, so this is actually disregarded anyway. For some reason it's bypassing that. Oh, because we're doing the strike, I'm sorry. But he is moving and walking toward us in between. You'll see that in motion in just a little bit. So essentially that's all the same, with the exception of he is attacking on the start point, which I may remove that if seems to correct a minor issue I'm having. Okay, so that's our change in our our animator flowchart here. What do you want to call this exactly? I guess it's a flowchart. Just showing how the states transition, the transition chart. It's probably a better term for it. Alright, so a couple of things that we did talk about last time, of course, was enhancing the AI a little bit more with the waypoints, so you can specify a starting and a start point and an end point. The other change I also made to the waypoint system was, well, actually it was not a change to the waypoint system. I did find we had a glitch where it was going to waypoint 1, 2, and it seemed to skip 3 and go to 14, and then come all the way around and come back up and then bypass 14 altogether and the return, and went 15, 16 when we had it going through every single waypoint. Found out what was causing that. If we look at our waypoints, let's go to 14 specifically. Let's do a top-down view. And let's see where 3 was in relation. Where 3 is right now, actually 14 wound up being exactly, they were like meshing, you know, almost on top of each other. And so there was confusion when it was running the 3, because 14 was slightly ahead, it hit 14 and was triggered as well, and then it just, when it came back, it just bypassed 3 altogether. So that was resolved by moving 14 over on a return side coming up. So that's been taken care of. Now again, this is just a sample circuit of waypoints 1 through 16. Ultimately, what I'd like to do, or what I will do, is in various parts of our map, we'll have, you know, a racetrack of sorts of the waypoints set out where it loops in a certain location, and we can have certain AI enemies travel certain waypoints to keep them contained within an area. The other way we could do that is through some kind of perimeter. We could have like a capsule collider or a rectangular box collider, some kind of collider, and set it as a trigger to keep them within the zone and trap for that on trigger exit as they're trying to leave, because they'll be inside the actual zone. So they're really not entering the trigger; they'll be exiting the trigger zone. So that's one way to do it. But I think the waypoint system is going to be a little bit more fluid, a little bit more dynamic looking. We can just control the exact path of enemies, and we can inject them into the path at any point and still have them follow and continue on. They'll go in this continuous path all the way through until they interact with, the player or something else that they need to interact with in the game. Now, speaking of interactions, we have this tiger that we've been working with. In the last stream, you saw that we actually had a large screen set up where we could watch him run through the waypoints. And so I kept that, and as promised, I went ahead and added the little picture-in-picture view down here. Actually, I have it set up back here now. I made it bigger. And down in the bottom right corner, there's a little smaller picture which shows a very close-up side view of our tiger as he moves, so that we can see when he's hitting the hills and going down edges, if he's missing the ground, is he floating, hovering, and it's going to help us troubleshoot some of the ground distance code that I'm working on to keep him close to the ground. So running on a flat surface is fine, just when you get into some areas that are like really slopey. Casual slopes are fine as well. Even I think you can do fairly well, about 25-degree slopes. Anything more than that will require some code to keep him down there, because the gravity alone is not holding him down, especially when he's dropping off a cliff. Let's see, I've got a list here. There are a couple other things that I did. So we have the ability to set the starting any waypoints. Did the picture-in-picture. And then, I smoothed out the waypoint turn, the rotation. When our enemy tiger was hitting a waypoint, he was basically just whatever he would directly face, instantly face toward the next waypoint. So depending on what direction that was, he could rotate instantly one way or the other, and it jerked the camera. You just kind of flickered real quick to another view, and it almost looked like he was being teleported, but really he was just changing instantly. So I smoothed that out a little bit. You see I've added some on the AI enemy controller down here. We added some additional variables that we can track, such as turn speed. We set that up. We had the walk speed, run speed, turn speed. We added a tracking. This is something new as well. I added tracking capability of our tiger when he gets near a human, which would be his opposing, his enemy from his eyes in this little project here. So if we get within a 30-meter radius zone of the tiger, he'll start pursuing us and continue to pursue us until we run inside the village here. Now, if you've been keeping up with the streams we've been doing, you're wondering, well, what would keep him from coming inside this Trader's Village? I wanted to make Trader's Village a safe haven, and I found a real easy way to do that, similar to the way we implemented our restricted zone outside the map. We used a giant capsule glider. We made the size or the radius large enough to go around this entire island that we've created, and we set it up where if our player hits that restricted zone, he's instantly spawned back to whatever currently Trader's Village, back to the spawn location there. So I did something similar, only since Trader's Village is a rectangular area. You'll see, let's expand it out, click on Traders Village, and let's zoom out a little bit. Let's go in the Y mode and come up here, and you see it's basically square. So what I added to this area was something called a safe zone, and essentially all it was a cube. I dropped in a cube, and the reason I used a cube, number one, it has all the components we need. It has really the box collider is what we need, but it also has the mesh renderer and the cube mesh filter components, which make it up so that you can visibly see. If I click that box there, you'll see we've got a white rectangular cube that encompasses the entire Traders Village area. And by unchecking the mesh renderer, we disable that component. So basically what we have then is just invisible barriers. And on the box collider, I clicked the is trigger to configure that collider as a trigger. And what that will allow is, instead of objects when they hit stopping in an invisible wall, it allows them to pass through, which is what we want. We want to go in and out of Traders Village. But we can trigger that event and react to it in some way and do something. And so that's what we've added for that. Like I said, we've also added tracking capability for our tiger. So we've got the tracking radius. In playing around with the AI scripting I've set for him kind of tracking us, I wanted to make sure that if we were walking and he was walking, that his walk speed would be more of a trot, a little bit faster than our player, and it would actually keep up with the player and stay on him. So the only way the player could get away was by sprinting, but when you sprint, it causes the tiger to start running and doing his sprint, and so it's a back and forth run. Eventually we run at a sprint, and then you're in trouble. And so I wanted a way to run into the village and create the safe zone, and that's kind of where I then added the safe zone area object, basically the cube, removing the mesh renderer, and set up as a trigger, and that took care of that. So we've got several variables here that help with the tracking. You'll see we've got an idle radius, walk radius, run radius, and the attack radius. So each of those are set to different values. The values I have it set to right now seem to work pretty well. It allows the tiger to do continuous attacks on us when it's right up on us, and kind of do while it's walking, it can walk right on us, at us, and it can attack as it's walking, and it's at the right speed where his collider is not actually pushing our character, because I have what we call the idle radius, and that is set to the right distance based on how we have the capsule collider set up, that he'll stop at the player and attack, continue to attack, as opposed to pushing the player by bumping into him with his capsule collider, and he can't really reach at that point when he's going into the attack animation. So and also I found the capsule collider did not work well for the type of attack I was trying to do. Since we were kind of moving, it was a dynamic move, it was continually moving. I even tried a couple different options to have with the collision, which actually don't have it on a capsule collider. I tried it with the rigid body that's on the tiger. There was something called continuous dynamic under right here, rigid body. Default collision detection is discrete. I chose continuous dynamic, which was recommended for that kind of collision. It didn't seem to work well, so I went ahead and did away with the on collision enter code. I got rid of that. So I couldn't use on trigger enter because we're using the physics engine. If we check this as a trigger, then it renders the rigid body, where it basically disables the effects of the rigid body, and it'll pull it through the ground because the gravity is set, and that was an issue there. So what I wound up having to do is to completely do this in code, and actually wound up working much better because based on what we learned before during the falling, we were taking fall damage to our character when he would jump off high areas above 10 meters, and we could calculate the distance from his feet to a point at the ground, and so we would capture that fall distance, and when he hit, we would apply damage based on the excessive fall height above 10. So the similar functionality, or the calculation was used for this, except there was no offset like with subtracting 10. I just took the absolute distance between our player and the tiger, and if that distance fell within our radius of our attack radius for the tiger, well then he could attack and therefore apply damage. And so I set up a attack damage here of 15 and an attack rate of a half a second. Basically that equates 0.5 is a half a second, so he's not applying the damage every frame. So there's a check in there, and basically the attack rate, and every half a second it can apply 15 more damage while he's while the player is within the damage zone. And so these right now, these are all the variables that I have incorporated, and I'm going to demonstrate how this animation works here in just a second. We may add more down the road, but this script here is coming along in a way that it should be able to be used with any enemy animated model that has a basic the same animations this has. So that we want to make sure we have an idle state. We want to make sure that we have a walk and a run animation, as well as an attack animation at a minimum. We're not actually implementing the roar yet. Again, that's going to be based on the hit. If there's, so that would be the hit animation from the player hitting the tiger. I'm not at that point where I'm actually attacking the tiger. I was continuing working on the AI side of this and making sure that it also works. And then again, with this safe zone I put in around the trader's village, that creates a trigger that sets a variable on the player, which I added a new variable in our player manager called is in safe zone. And so it's set to true when he's in the safe zone, false if he's not. And so that is one of the checks that the tiger will do. His AI logic will do that if the player's in a safe zone, he'll no longer do the tracking code, because when he starts in track mode within a certain radius, basically the tracking radius, that there's a flag that's set and he'll continually go on that. So if the player's in a safe zone, then he kind of lets up on the tracking and starts walking away, going along his way. We had him on the course to go down some waypoints. That's the way he's set up. There's two random waypoints that are points that are picked out through a random function, a starting and a destination, or a final destination, a starting destination. And so he'll continue on trying to get to that point. But if he's interrupted, like if we get near him while he's going there, he's going to pursue us. But if we get to a safe zone, you'll see that he'll stop pursuing us and continue on to his, his original destination. So let's go ahead and run this so you can see how this is working in action. Just wanted to keep this stream short today, just to go over those changes that I did enhance. I don't think I'm leaving anything else out. Okay, so here's our player. I changed the spawn location out front so he's further away. You can see our tiger walking there behind the tree straight ahead. So watch, when I cross over, you see he's sprinting at us now. So we're going to run. We already took a little damage there. He struck one time. Got some damage because we were in the damage zone. Sprinting away. Let's turn around and see where he's at. Whoops. Got right on him. He took more of our shield down. I want to get where these doors are so I have a quick exit. So I'm going to show if I'm right here. So he's striking, taking damage. We're still taking damage, taking damage. Let's try to run in the hole. Boom, we're here. We're safe. Uh, since the safe perimeter is set just outside the walls, there's like a 3-foot area. You can just get up against the wall and you're safe. You don't actually have to go in the village, but let's do this. Let's speed up, sprint up, see if we can catch up to him. As you can see, we're able to bring him up, chasing us again. As long as you're sprinting, he's never going to catch you. Matter of fact, we got in the safe zone, and so he went away. So I didn't realize I crossed into the safe zone. Now, I did set up the waypoint system, or the running of where he initially starts out. He's walking slow to the first one. He'll sprint through every other one. And my frame rate is really low right now because I'm running a bunch of stuff here in the background, and normally the frame rate is much better, 30 to 40. Like I said, I ran this on another system that had a decent setup, and I was getting a steady 60 frames. So it's my older computer that's causing a low frame rate. It's not that Unity cannot perform. I mean, it can support it. So what we're going to do now, since he's already way ahead, I can't catch up to him without having any more stamina. Yeah, my stamina ran out again, so we're going to jog down to our big screen TV in the back there and just keep an eye on him. Remember, we had set up the main view to monitor him from up in the sky from a camera that's attached to him, so we're able to see him traverse the waypoint system, and we get the close-up view with the picture-in-picture on this as well, so we can see. Alright, so here we are. Found that the best view is going to be, there he is, he's still running. You can see he's running, standing about right here. About that view. Let me back up just a little bit. Alright, so we get that picture, and you see the smooth when he's turning, hitting them waypoints. You see it's like a smooth rotation. And so at sprint speed, I mean, the animation looks really good for him. It looks somewhat realistic for an animated character. It looks really good. See, we had a nice little turn. Even that turn, it was fast, but it was, that was almost like a 180. It wasn't as extreme as it had been. So he's going to be running back through the stretches, and I don't know. Let's see something here. Let me just pop this up, and let's scroll here. Waypoint 16. Let's see. His starting waypoint was 2. His end was 14. So he's going to get pretty close to the top here. Let's go ahead and sprint through here. Let's grab some of these. Remember, we had our pickup system working before. We can pick up some of this. I'm just jumping all over the place. Let's get some first aid. Alright, so I'm going to hit 3 to use one of those. 3 again. 1. 4. So it gave us a little bit of health. Got enough that I believe we could outrun him if we had to. Now he should be stopped at 14. Waypoint 14 should be, I'm looking at our little mini map there. Should be just at the base of this here. He might start charging us because if he's already there, because we'll be within his 30-meter radius. I was hoping we get there before he arrives. There he comes. He's back up. I wanted to stay out of his radius just to see. Okay, so he went through. His last stop should be just up over that hill there. So you see we're a safe distance away here. But we can see how close we can get to him. Okay, that's 14. We're 4. I thought it was down there. That was 13. So you see we're moving in closer, closer.
It's hot as hell in here, dude.
Turn the AC on. Up.
I did. Please stop freaking out.
You'll see if I'm running like this, I'm just walking. I'm not sprinting. I'm taking damage. Boom, and all our damage, all our shield is gone. We're taking 15 damage every strike. So he's doing his animation. One thing I don't have in there is blending of the animation. So when he's doing the attack animation, he's not able to do the walk or the run. He should be in a walk mode right now because I'm only just kind of jogging. But when I sprint, you see he'll start. Oh, we're in our safe zone, so he ran away. Went back to 14, got snagged up. Nope, came back out. Okay, I want to try to sprint so you can see what he's doing here. He'll sprint when we get a certain distance away from him. He starts sprinting back at us, and then he'll start walking, slowing down. Now you can see I ran out of stamina. His walk speed is a little bit faster. He will eventually catch up. Okay, we went in the safe zone, so he ran away. So he'll start attacking her. Every time he's attacking, he's hitting damage. Of course, we can't take any more damage, and I don't have the die implemented yet. We don't have a die animation. The only thing we can do is just right now pop up a no, you've died message on the screen. Now let's see how he's going to go. If he'll walk, he's kind of hugging a building, but his capsule glider is keeping him from getting stuck. That's probably why he got stuck on that other thing. I had to change the size of his capsule glider. It was 2.25. So he is kind of stuck there, unfortunately. See if we can help him out, bring him out. Alright, we're going to sprint. So yeah, the basic AI is there. He's striking us at this point. We're within the strike radius of 5, so we'll be taking damage. In fact, let's do this. Let's see if we can see what's going on here. And there's our waypoints triggered. I was just trying to look for. Oh, that's right. I forgot. Yeah, I thought I was showing the messages when he's attacking. Let's see, where is that enemy? Okay, here it is, right here. Enemies attacking with 15 damage points. I don't know. I must have turned on an option because it's stacking similar messages. If they're the exact same message, it'll stack them, which is kind of nice. But it makes it hard to look at because it's not showing it sequentially. by the order that they were logged here. And that's kind of what I originally wanted, so you can look at it. But it does help. You can see this count is going up. He is causing damage. That's how many times he's causing damage. Every half a second, so it should be 2 times a second. Yeah, so I'm kind of excited about all this. It's all working well. Got this AI working. I'd like to bring in another model and throwing some damage, throwing some different damage parameters and some other radius here. Maybe make the radius smaller for the trigger zone, for the tracking radius. I just need to play around with a few other things yet that I want to tweak here before I do that. One being, I want to have our player, since he can shoot, let's get him in here. Let's go ahead and maximize this the best we can. Just go grab some health, just so we've got some health to show. I want to grab a gun if we can find one. Should still have a respawn spot out here. Yeah. Let's pick that up. Let's equip it. Let's over bullets. Now, I'm dropping to about 15 frames right now, but normally, like I said, 60 frames, you'll actually see the bullet. You can kind of see the bullet hitting the ground where I was aiming. You have to really look. It's like at the bottom right of the crosshair. The bottom right point, not the all the way at the bottom right. Yeah, so the next thing we need to do is take this gun and actually the bullet logic, we need to go look at that and see if we can apply some damage to this tiger. And so we'll work on that, and then just so we know what damage he's at, we'll look at adding a floating health bar above him, so we know at any given point what his health level is at, what level he is. Was he a level 1 tiger, level 2, level 3? We'll just kind of put that in there and build it in to show the level or the rank of the enemy, because the enemies will be able to rank up as well over time as they battle. They get stronger. So I'm going to write that down, the things that I'm going to go ahead and do. I'm looking at my other list. I've got everything checked off. So yeah, we've been moving along pretty good. I've been more or less the 3 or 4 things I say that I'm going to do, I try to do it by the next day. So keep in mind, these small changes I'm showing you are generally done within a day, and I am working a full-time job. So like we were on stream yesterday. I had a video I posted sometime in the afternoon. So it was since yesterday afternoon and little time I had this afternoon that I had these other changes already done. So the idea is for me just to enhance this and make some changes every day. So if you are one of these regular viewers out there and you're watching, you can see this thing evolve over time, and instead of me doing like a week at a time and just trying to do a video and showcasing all this stuff, it would take forever to go through it. It takes long enough just to go over a few simple changes that I've made and to show the results of how that worked. Let me go ahead and stop this right now. And I'm trying to think if there's anything else I need to go over as far as any changes. I guess I could show you the safe zone manager. This will be used, or can be used. Well, since it's attached to the player, well, actually, I'm sorry, it's not attached to the player, but interacts with the player directly. This is for the player when you go into a safe zone. The player has on him, if we go look at our player manager, we've got a new property called in safe zone. It's a getter and setter. We can read the value or set it. And of course, the internal variable that's set up is defined up here, somewhere up here. Yeah, in safe zone right here. So we've got that defined up there as a boolean. So it's going to be a true or false that'll be returned back. And so essentially that's it. That was added for the player to support whether, because they only need a state. It's more or less a boolean variable to indicate a state. Is he in the safe zone or not, so that other entities can actually read that property off the player, so they know how they need to react around the player. And so looking at our safe zone manager code, it's really not a lot. I mean, this isn't even used. I could take that right out of there. But probably not hurting anything to leave it. We'll eventually maybe put something in there. Okay, so looking at the code, I could use an if statement here because it's only one object here right now, the player. But I decided to use a switch so that as we add additional interactions, this collider, the safe zone, could interact with multiple players, multiple NPCs, multiple enemies, which, you know, and so we might need to expand on this. So I went ahead and set up as a switch, and it just there's a switch on, you know, the collider gets passed in as a variable called other, and other every object that's passed in, whether it be a collider or whatever, if it's not the parent object, there's always a reference to the parent game object through the .game object property. And so once you access that parent object or container, the game object container for this component, you can then access the tag. And so that's going to be pretty common. You'll see that quite a bit. So we're passing in the or doing the switch on the tag, and if it's player, which is this is our player is set to that, it'll do this. It logs, hey, the player entered into safe zone A, which because we're at location A, I call it safe zone A. And then we actually just set the in safe zone value on the player to true when he's in the zone. That's on the untrigger enter. Now on the untrigger exit, when he leaves the safe zone, we do the exact same thing, same code. The only difference is we're changing that to false. So in safe zone set to false. So that's how the safe zone code works for toggling the player status, you know, off to safe zone status to true or false. And now let's look at the AI enemy code because there were some changes in that. So of course we got our public variables that show up in the inspector. Got a bunch of private ones. And you know, we got variables like last attack is what tracks the time, so that we can determine once the tiger does attack. Excuse me. It will store the last attack time in there and know that he cannot attack until the next attack time, which is you know, the half second that we set up in the inspector. Yeah, so looking at there's some properties that are set up for some of this stuff. Is roaring his head, is attacking. Probably not going to be using his roaring anymore. I'll eventually remove that. I was just trying to name the properties the same as the animation states, but it really makes sense. Like if he's hit, then he's going to get agitated, so he'll roar. And so that's what I was thinking, why I changed that. Alright, so our basic code is the same. None of this has changed in the start function. That's all the same from before. Now the only thing that was added in the update was our track player function, and I put it in a separate method so that it can just be called. It's really not a function, it's a method, but I put it in this method so it can be called in the update like this, and it's really clean and easy to look at. You know, we do our move calculations, and when we check for tracking the player, and after those two are done, um, you know, these variables are set. The underscore move is attacking and is hit are actually set, and we can pass those in to our animator controller. So those values get mapped to the speed is attacking and is hit that are inside our animator controller. And that's how it triggers the animations based on these values being passed in. Again, remember, update is called every frame. So every frame, the animator controller is getting updated values for those. I had this little snippet of code in here to cause the tiger to, you know, once he got spawned in and he started walking, to have him immediately after 2 seconds, not immediately. I have a 2 here for 2 seconds. To force him to start running before he hit that first waypoint, just to speed up the process during testing. I removed that or commented it out. I didn't want to delete the code because I think maybe I could use it somewhere else. So I just, and then rather than having to write it again, I just can copy and paste it. So anyways, I commented that out, and it wasn't needed no longer because I wanted him to be walking slower, where my player had enough time to run within his tracking radius and get him to start following me. So I removed that. So looking at the move, okay, here's, in order to do the smooth rotation, we created a new float variable called rotate step, and we're taking the turn speed value, which we pass into the inspector, and that's something that I kind of played around with to get the right number, but it let me do it easily in the inspector. And then once I have my value set, you know, I left it. And then we multiply by that time.delta time, which we've seen time and time again to get any kind of smooth animation, smooth turn, smooth anything, or any kind of incremental value over a frame. And you know, the time.delta time gives us the proper turn. Like if we were to view that turn going at 16 frames a second versus 50 or 60, it would pretty much look the same because of, again, using time.delta time. So keep that in mind. If you're ever working on stuff and you get a real jerky kind of movement, you're going to need to use time.delta time to get, you know, it gives you a slice of time, what time it took for this particular frame to execute, and then uses that to apply that. And I'm assuming since the frame's quite not over when you're calculating this stuff, the time.delta time is really the time in seconds it took to complete the last frame. It does say last frame. I was thinking it was the last frame. So whatever that time was for the last frame, you use that as a factor for the current frame. And you know, each time that delta time is going to change from frame to frame, because it's all going to be a portion of a second, basically, whatever your frame rate is per second. So the times can fluctuate, and the end result is over the course of a second of time, you'll get the same variation and changes across that second because of the frame rate's not going to be, it's frame rate independent. It's the easiest way to say it. Okay, so originally I had this transform.lookAt, and that just caused it to quickly look at that destination position, which was the next waypoint. Instead, we had to do a few things, and I did have to do a little research and look at, you know, some example code and to come up with this, but and I was able to incorporate this right in here from an example, actually. So essentially what they're doing is setting up two variables. One is going to be the target point, and the other is the target rotation. And then this quaternion.slurp will take the current rotation of your the rotation of your transform, which is the object. You know, in our case, it's the enemy object, the tiger, but it's the transform. and then you pass it. That's the first parameter. The second parameter you pass it is the target rotation that was calculated in this step here. And the third thing you pass it is the rotate step, which is basically again an incremental value of the total rotation that it needs to rotate for this frame. And that was it. So this was the key, using this quaternion dot, I guess I don't know if you call it slurp or slurp, but it's a variation of the lerp. And now to calculate the target rotation, again, this function look rotation, the reason it has to be used is because these values that are being passed in, the target rotation, has to be a quaternion value, which is it has 4 values that represent that particular rotation. So that's why we had to use this quaternion.look rotation. We pass it in, as you can see in there, we're passing in 2 vectors, the forward vector and the up vector. Forward vector being the direction that you want to look, and basically you can get that through subtracting the target point, which is our destination point. So in our waypoint system, the next waypoint that our tiger is running to is the destination, that position, the next target point, and you can subtract your transformed up position. That will give you the forward vector, the direction, and then you just pass it. The second vector actually indicates, that's the shorthand, that up is the shorthand for indicating the y-axis, basically. So you're going to rotate on the y-axis. So that's the target rotation. So that's the point. Essentially, it's the same as this. We probably could have used, I mean, we could have used, well, we really couldn't have used, but this gives the same value, this transform.look at, but it's not in quaternion format. It has to be a quaternion because it needs to be passed in here as a quaternion. As you see there, it takes quaternion A, quaternion B, float T. T is the slice of time. But that's it. This right here does the rotation along with this float rotate step. There's a few calculations that need to happen, but this is pretty standard. I was even thinking about taking these lines of code and putting them into a function that I can pass in, for example, the turn speed, because that's what it really needs. The turn speed, the target point, the transform that you're trying to do this rotation on. And that's pretty much all you need, because based on those 3 parameters passed in, a function could be created that does the smooth rotation. Matter of fact, let's just do that real quick just to show how easy that could be. Alright, so let's go ahead and copy this code here. Actually, we're going to delete that one line. We don't actually need it, but let's copy that. We'll create our function just right above the move so we can see it here. Private. And we're going to be returning back. See, the rotation takes quaternion. So we're going to be returning back a quaternion. We'll call this smooth rotation. And I'll pass those parameters in just a second. We just type that code there. Like I said, we're going to get rid of this one. That's part of the, that's actually the step for, let's go ahead and move that down to here. That's the step that's used there for the positioning, the location in space, not the 3D space, not the rotation. So we'll delete that one that we didn't have. That was not a smooth. Let's do that. I just want to keep all
Turtles
this.
is out here now.
Who is?
Turtles?
She got out?
Yeah, I'll let her out because she kept staring at the door.
Yeah, that's fine. She can come out. I'll let her come and go. That's fine. Alright, so let's paste that in. Okay, so now smooth rotation is going to need 3 values. We're going to need, like I say, we'll need the turn speed. We're going to make this a self-contained function, so if we want to copy it somewhere else and use it, we can. So we're going to use some other values, even though turn speed is accessible in this entire script, as well as, I guess we need our target point. Okay, so what we're going to do is we're going to say we'll just call it we need a float turn speed. We also need this target point, which, let's see, our position, it's a vector 3. So we need a vector 3. We'll just call it target point. Okay, so I'm going to fix those errors in a minute because we're going to shorten this up actually by doing this. So we got our turn speed, our target point, which is our destination, and then we need, should be just our okay, so the quaternion.look rotation takes in 2 vectors and then returns back a quaternion. So so we really don't even need the transform. We just need the position of the transform. So we need another vector 3 actually. I had vector 2 there. Let me change that. So we need another vector 3. And they call it target point. I'm just going to say destination point. And then another vector 3. And I don't know if I should call it start point or current point. It's really the current position, so let's just call it that. Current point. Point is a 3D point 3D space, XYZ vector 3. Okay, so that should be all we need to actually execute this. So okay, so then we'll say we're returning back a quaternion. Remember that. So declare a quaternion result. We're going to declare that. We're going to turn it here. Return result. And so it's possible we can do all this in one line here. That's what I'm looking at. Yeah, let's take this line. Move the hair. So the target rotation is going to be the destination point that we're passing in minus current point, not transfer that position, and we're going to rotate on vector 3.up is the shorthand for it's 0, 1, 0. If we look at this, vector 3, 0, 1, 0, which means that we're going to choose the middle parameter of 1 indicates the y axis, the y that the rotation on the y axis. If it were vector dot forward, it would be 0, 0, 1 for the z-axis, and vector dot left or right is the x. It's either negative or positive. Actually, up and down is the y, positive or negative. But so we use vector 3 dot up on this. Yeah, so that's all we need. We subtract the destination point minus the current point. That'll come up with, Unity actually has built into their functionality where you can actually subtract 3D points. You can't really do this in regular mathematics. Like if you're in math class, you don't necessarily just subtract 3D points with a subtraction sign like that. There's stuff going on behind the scenes that they handle for you, but you could take your current point, destination point minus your current point. That'll give you and then you pass in the basically the difference in the y, and it will rotate that difference from where it's at to where it's going. Anyway, so that should take care of that. That gives us our target rotation, and then let's see our turn speed. Yeah, rotate step is really just this here, so there's no sense doing it on a separate line. We'll just embed it in here. So we're going to take this line of code. We're going to say that that equals that, but then this rotate step is actually going to be the turn speed. It's being passed in, not the underscore one, times time dot delta time. So we can get rid of that line. We can get rid of that. We can get rid of that. So that's essentially what we're left with. So looking at this now, so we get our target rotation, which is a parameter that's needed here. Now if we wanted to, I mean, we could take this and put it in here, but there's really no need in it. It's readable right now with 2 lines without being, not readable enough. So it's taking information being passed in there. So now how do we use it here? Real easy. I'm going to put this underneath these. Essentially, we're going to block out all this code now. This whole block right here. Right there can be gone, and then we can say, I'm going to highlight this. Transform.position is what we're setting here. That's the final. Oops. I'm sorry. Here. We need to leave the float step speed up. Yeah, we need to leave that. That's our position. Let's leave that. We don't need that. It was something I was doing before. It didn't matter. Okay, yeah, so this is what we're replacing. We're replacing these 4 lines of code with 1 line of code now. Transform.rotation equals smooth rotation. And then we just pass it in the values it needs. Now we're passing in, we got a turn speed, so it's underscore turn speed, which is coming from this entire script. Like I said, we could access it directly in the function, but I wrote the function where it was independent of anything outside of that function. And so if we wanted to actually move that function to a utility class, we could, and put it in a class that's static, so we don't have to create an instance of it, kind of like we did with Harvest Globals. We can just type Harvest Globals dot and some of the properties in there. We could move this into a utility function, because a smooth rotation is needed often. And so rather than have those 4 lines of code written everywhere in every script, even if we reduced it down to the 2, you still got 2. We can do it in 1 here. So turn speed and it's a reusable function, media functions methods, reusable. Um, so turn speed, our destination point, which we said was destination.position. That's what we originally had. And then the current point is transform dot position, the transform of our current game object, which is our tiger here that's running, our enemy. And so yeah, we've reduced that now to a single line of code. So we do the rotation in one line, and then we do this here. And actually, I'm going to change this because that's almost too simplified there. For once you see this often enough, we can just drop it in. It'll do speed times time.delta time as the parameter instead of doing that. So we can reduce this down to 2 lines of code here. That'll do the same thing. Now, to make sure that we didn't muck this up and make sure it still works, we're going to go ahead and run this in just a second. Waiting for it to finish compiling. I'll know when it's finished compiling. I'll get about 5 yellow warnings here. There they are, 5. Most of them are not my code, some are. Alright, so we can clear that out. Now let's run it, and what we're going to do to see it in action, we'll have to run to the back of the trader village. See if we can trigger that little tiger. Sure enough. Don't hurt us. Don't hurt us. Alright, so we'll go here. We're safe. He's walking away. Alright, so we're going to run straight through. Let's pick up a few blue bottles on the way. Go ahead and drink that. 3. Bring that armor up. We're going back here to watch some TV. So let's watch him turn on the big screen, not the small view, not the picture-in-picture, small view. See, you saw that turn he just did down the slope. There's going to be a more extreme turn down here, you'll see. I mean, the smooth turn still works, still all working, it's not a quick jerk. So we simplified it, made it, for me it's easier to read when you simplify and work with functions. I try to do that anywhere possible. So that's probably going to be it for tonight. This stream actually was a lot longer than I had anticipated. I think I did it over an hour. I didn't expect to go that long. I do have work in the morning. Yeah, you can see some areas where when he's running fast, he's not being held properly in the ground. You need to figure out those details. On flat ground, he's perfectly fine. Again, it's just an animation, so it comes down to rotating the object at his pivot point, which should be in the center. So it's about rotating him when he's going downward on a slope. You want to rotate him forward. When he's going up, you want to rotate him upward so that it appears that his feet are stabilized in the ground. Extra mass will keep him in the lower valleys like that. I think I changed the mass. It was 150. I set it to 50. So that's why he's coming up a little more off the ground. So anyways, you see it's all working in our big screen. So we'll call that a stream. Thanks again for stopping out. If you haven't subscribed already, go ahead and subscribe to my channel. You'll get notified when I go live again, which has been pretty much, for the most part, every other day. Sometimes back-to-back days. Just kind of varies on my schedule, what I'm working on. Um, I know there was one time I wanted to do a stream the next day, and I wound up pulling my hair out over some stuff uh, that I was working on here in this project. It didn't quite work out well, so it took a little research, and like I said, I'm learning as I go. Everything you've seen in this so far has been a learning process, and we're learning. It's a never-ending learning process, which is what I love about it. So hopefully, if you're into game development and this is something you enjoy, hopefully you'll, uh, you know, spend the time you need to really understand it and learn it, because it makes it that much more fun and exciting. And it's if you don't put the time in, or you might learn something and then you step away for it for a couple of weeks, you may or may not remember that. This is something you need to spend time with every day. So it's best if you have any idea that you might want to do some game development in Unity, at least set aside a little bit of time. I'm not saying do like I'm doing, which is several hours a day. You can just set aside 30 minutes and just kind of either watch a video, try to figure something out, read up on something in the documentation, and then try to implement it in code and see how it works. Just start playing around with the functionality and the built-in classes that are part of Unity, and how to access certain components, and there's a lot to learn. I mean, just I've finally gotten comfortable with their whole component model, which was different from a lot of the C# stuff I did, where you create a class, and then you have to create an instance of the class by using the new keyword, and you don't do that in a mono behavior script. If it's deriving from a mono behavior, you cannot create like an instance of that class by using the new keyword. What you'll have to do is reference the game object it's on, and then use the get component with the left and right brackets, greater than less than symbols, with the script name contained in there, which becomes basically the data type you're searching for, more or less. That is the name of your class in that sense, and you can get and you've seen me do it. So, but there's just some subtlety, some differences in the way the component, the way you access stuff. It's all based on using get components. Now you can still create traditional classes, C# classes of your own, and you just make sure you don't derive them from mono behavior, and then you're able to use the new keyword just like you normally do in C#, all that. So it's a cross between that, a best of both worlds, really. Anyways, thanks again for stopping out. I enjoyed it. It's getting late. I'm going to go ahead and get me some shut-eye here. I've got work in the morning. So hopefully you enjoyed this and you learned a little bit from it and saw some progression. So we'll keep this rolling. Y'all have a good night. Oh, hi, babies. Hi, babies. Oops, I'm sorry. Hello, babies. Hello, babies. You are a sweetheart. You little kitty, you are a sweetheart. You are.